Okay, so the symbol for the element is an abbreviation usually of the element name. So in the next part of the periodic table, we'll look at where they get their origins from. So sometimes it's the same, begins with the same letter that it starts with, but not always, that's not always the case. So for example, iron, the symbol is Fe. And that's because it's taken from an abbreviation of its Latin term, which is ferric. So usually it's either an abbreviation of their name or a Latin or Greek version of their name, okay? But it always starts with a capital letter. Now, if there are more letters, so for example, there are many elements that start with the letter C, but you have to obviously distinct them from one another. So usually another letter is added on, but any other secondary letter has to be lowercase. So for example, carbon is capital C, calcium is capital C with a lowercase a, but it must always start with a capital. So the atomic weight is also known as the atomic mass. So this is the mass of the atom. Okay, so when we look at the atom later on, this will sound familiar, but basically the majority of the mass of an atom is coming from the nucleus or the center of the atom. So that's where you find the number of protons and the number of neutrons. So this atomic mass is basically a combination of the proton number, which is the atomic number, plus neutrons. So protons is 6, and then of course this would be plus the neutrons. So you can see here that there are 6 protons, so that means there must be 6 neutrons to add up to 12. But don't worry about that. I just want you to realize that that is the atomic mass, and that's the weight of the atom. We'll look at protons, neutrons later on when we look at the atom structure. Okay, so we talked about the organization of the periodic table a little bit. So we know already that horizontal rows are periods, but actually the vertical columns have a name as well. So they're called groups. So there are 18 groups on the periodic table. Let me quickly get this here. So as you can see here, right? Let me get this all in. You can see the number up at the top. So this is group 1, group 2, 3, 4, 5, 6, all the way to group number 18. Okay, so there are 18 groups. Sometimes these groups are also referred to as chemical families, and that's because a lot of the same elements that are in a group together, or the same vertical column, they have similar properties, just like families have similar characteristics to each other. Maybe everyone has brown hair, or everyone has, hazel eyes or something like that. Genetics plays a role in it, obviously. But a chemical family or a group are also similar because they have patterns or qualities that are, very similar to one another. So of course, periods, we had already talked about this. So they're the horizontal rows. There are 7 of them. So there are, of course, we have 18 chemical families or 18 columns on the periodic table. There are 4 that you are expected to know. So the first 2, so this is group 1 and group 2. And then the last 2, group 17 and then group 18, okay? So the alkaline metal, alkaline earth metals, the halogens, and the noble gases. So the alkaline metals is the first group on the periodic table. Okay, the only element that is in that column that actually does not belong there in this family, it belongs in column number 1, but it's not part of this chemical family, is hydrogen. So when we talk about the alkaline metals, we're talking about everything in group number 1 except for hydrogen. So if you take a look here, so even the colors that are here, so the alkaline metals, it's telling me more about the alkaline metals. So the alkaline metals are here. Hydrogen is not included. Now, the reason why hydrogen is not included is because it doesn't fit the characteristics of this family. So all of these elements are solid, all of these elements are metals, and all of these elements are very reactive. Hydrogen is a gas, and hydrogen is not a metal. So it's kind of like one of these things is not like the other. Okay, so some examples. I just picked 3 elements, but those are 3 elements that are in group number 1. So they're all shiny. They all have luster. Majority of them are silver in color, and this is the most important property that we have there. Of course, they're also metals. It's in the name. They're very reactive. So actually, they're the most reactive metal group on the periodic table. So as you go from left to right, the metals become less and less reactive. So the most reactive is group number 1. The second most reactive group of metals is group number 2. The third most is group number 3, etc., etc. for metals, okay? So the second column on the periodic table, group number 2, so every element in group number 2 is included here. I just picked 3 from that column, so beryllium, magnesium, and calcium. So they are still reactive metals. They're just not as reactive as group number 1. Okay, all of these metals are grayish in color, like a dark gray, and they also have luster. So the halogens are group 17. So now group 17 is actually not a metal. They're called non-metals, okay, because they're not metals. So group 17, all of the elements are included in that second last column. So I just picked 4 here. So fluorine, chlorine, bromine, and iodine. Now group 17 is the most reactive non-metal group. So the most reactive metals are group number 1. The most reactive non-metals are group 17. Okay, we'll get into a little bit later on why are they so reactive. It has to do with their atomic structure. So we'll look at that later on in this unit. Okay, so because these elements are so reactive, so the alkaline metals and the halogens, both of them are very rare to be found by themselves. Normally, they are combined with other elements because they are so reactive. Okay, so the halogens actually have quite a bit of use for us, like in terms of everyday life. So chlorine is actually a big disinfectant that's used in drinking water. So it helps to kill different bacteria, or if you like to go swimming, it's used to kill bacteria that are in pools and hot tubs. And fluorine is actually added to our tap water, and it's also in your toothpaste. So it's there to basically keep our enamels strong. So that way it has a protective layer on there. Okay, and then the last column is called the noble gases group. Okay, so every element in group 18 is included in this. And they are essentially all gases. They're all non-metals. I chose 3 of them here. So helium, neon, and argon. So actually here is some neon right here in the neon light sign. Now, these gases and these elements are the most unreactive gases in the periodic table. So they do not react with pretty much anything, okay? So that means that they are always found in their natural state because they do not like to react. Now, these elements, just so you know, are very easily transformed into plasma. So meaning these gases are used in these signs because when you add electricity, it gives off a light. It is now excited, basically gas that has additional electricity that's been added in, which we looked at the very, very start of chemistry. Okay, so the elements in the periodic table, we're going to end off with this here, are essentially divided into three main groups. We have nonmetals, metals, and metalloids. Okay, so looking at the periodic table, majority of the elements are metals. So this left side here. Non-metals are on the right side, and of course, remember this is our hydrogen. Hydrogen is included in the non-metals. Okay, but the metalloids are this middle section. So basically, every periodic table has what's called this staircase. Let me see, does my online version have the staircase? Technically not. Okay, but anyway, the staircase is actually, I don't know if this will let me, no. The staircase begins here and basically actually begins where boron is, and it works its way down, okay? I know that this periodic table does have that. Maybe not. I'm going to draw it in. Can I do that here? Okay, we're in business, I think. So this is where our periodic table staircase is located. And let me zoom out for a second so you can actually see this. Okay, so the staircase is really the separator from metals to non-metals, okay? But the elements that are along the staircase are known as the metalloids, and it's actually not everything on this staircase. So aluminum is a metal, and acetine is a non-metal. So it's the other elements that are on this staircase. So boron, silicon, germanium, arsenic, antimony, beryllium, and polonium. These are your metalloids, okay? So metals have one set of characteristics. Non-metals have another set of characteristics, which we're going to get into a little bit later. But the reason why we have these metalloids is because they don't really fit into one of the two other major categories. So I'll give you an example. Metals are able to conduct heat and electricity. Non-metals aren't. Metals are shiny and non-metals are dull. They're not shiny. So when we're talking about metalloids, they have a mixture of the properties. So you can have a metalloid that is dull, so it's kind of dull like a non-metal, but it conducts electricity like how a metal does. So they're like a hybrid mix of the two. They don't really fit into one or the other. So they kind of made their own category of the mishmash elements. So they're called metalloids. So we'll look at these main categories after when we get into our second part.